Hello, and welcome to your third lecture. This is actually the end of Unit 1, so this is the last one before the next class will be a review day, and then the exam will be the following day. For the exams, you just take the exam at some point during the day. We switch over to, no, sorry, our learning objectives. So today we are going to just talk about mathematical sentences, how to translate, no, we've already translated, right? We'll just talk about the equality, the language of equality, using operations and order symbols. You will identify identities and inverses. I know that sounds confusing, identifying an identity, but an identity is a math term. And then we will use the distributive property only. I'm cutting these two out. These are not on the exam. They are not important in this class. So we're just going to practice. I'm only going to teach the distributive property. You're only going to practice the distributive property. You're going to write algebraic expressions and simplify algebraic expressions using like terms. All right. So what is an algebraic equation? It's a statement that two expressions have equal value. So in 1.2, we talked about expressions. An expression doesn't have an equal sign. If you add an equal sign and then something after the equal sign to an expression, it becomes an equation. Okay, so equality just means the equal sign, and equations will always have equality. If it's an English sentence, it'll have something like equals, gives, is, was, should be, yields, which is the same as gives, amounts to, represents, and is the same as. So those all mean equals. Equals means an equal sign means you have an equation. All right, so to begin with, we're going to write a sentence as an equation. What I like to do is use a highlighter or some sort of coloring system, as you'll notice throughout the semester, overuse of coloring systems. You want to take each term and decide what it means in translation. The difference of. So when you think about difference, the difference of 7 and a number is equal to 42. The whole phrase, the difference and goes with that. So it's the difference of two things, right? Difference means subtraction. If we're subtracting, we have to subtract two things. So the difference of two things means that and is part of the difference phrase. It goes with difference, okay? The difference of 7 and a number is equal to 42. Remember that anytime you have a number, it could mean any number. In turn, any number, you switch with a variable, any letter, okay? I usually use X because it's the most commonly seen. You can use Y, you can use your favorite letter, whatever you want, as long as it's easy for you to see. And often, if you're doing an assignment, it'll tell you what the variable is. Use X as your variable. The difference of 7 and a number is equal to 42. So we know difference means minus. A number means a variable. I'm going to use X. Okay. Is equal to, we know that one too. And then we just have our numbers. Remember, you always want to think about what order should it be in. Okay, the difference is straightforward. There's no need to change the order. Okay, subtracted from would change the order. The quotient, the next one is the quotient of y and twice x is the same as the product of 4 and z. Feel free to pause the video, try to figure out for yourself what the terms are and how you would write each of those terms as a symbol. The difference and, I wrote a subtraction. That's a number, so I just carried them straight down. A number, I wrote as the variable x, and then equal to, I wrote as the equal sign. Pause the video, try to do it yourself. See how many you can pick out, okay? Thank you. The quotient of, again, the and goes with the quotient of. I'm clarifying this because sometimes and means plus, right? If I had 7 and 3 is 10, that just means plus. But in this case, the quotient of and makes and a part of the quotient. So you need to decide, does that mean plus or does that just part of the phrase? Good. Quotient always means divide. The quotient of y is kind of like the number 7, we know what that is, twice x. So I would pick out twice. I don't want to use blue, right? Twice. Twice means I'm multiplying it by 2. So you could even write, you would write 2 and put your variable right next to it, or you could put 2 and then a multiplication sign. You could even, if you were extra smart, put 2 in parentheses just to be safe so you don't get confused. Twice x, y, and x, we're just bringing straight down like we brought down 7 and 42, is the same as was one of the equality signs or phrases. The product of is a bit like the quotient. The quotient of and means divide. The product of means multiply. So on this side of the equal sign, I have a division bar. On this side of the equal sign, I have a multiplication sign. The product of, and again, it's pretty straightforward. We're just going to bring down the 4, bring down the z. Okay? I called it a division bar because you can also write y divided by 2 times x as y over 2x is equal to 4z. That division symbol is also a fraction bar. They both mean divide. So either answer is okay. Or y divided by 2x equals 4z, just to get rid of some of the symbols, the multiplication symbols, because we know if they're right next to each other, a variable and a number are right next to each other, it does mean divide. So that's equal to that, which is also equal to that. Equality and inequality symbols. So equality, we know, right? We saw those. Equal sign. Inequality, all we know about it is it's not equal to, right? They have a relationship. The relationship is not equality. It's not equality, it's inequality. A is B, A is not B, that's all we know. A is less than B, A is more than B or greater than B. This one combines both the equal sign and an inequality. Okay, so we say less than or equal to, greater than or equal to. Good. So the arrow is always pointing to the smaller number. Okay. You guys learn in elementary school, alligator, eat the bigger number. So it's like an open alligator mouth to the bigger number. But it is helpful just to memorize that that is the less than symbol, that is the greater than symbol. Okay. Now, they are asking us to insert the less than symbol or greater than symbol between pairs of numbers to make a true statement. Okay. Hold on one second, I'm going to pause. Was not prepared, and my ruler, my straight edge was under my computer. Okay, I'm going to make a number line to add a little clarity if you would like some clarity on greater than or less than. Okay, here's a number line. The middle of the number line is 0. Okay. To the left of 0, we have -1. To the right of 0, we have +1, right? So you should, when you're picturing a number line in your head, comes up a lot, I'm sure. When you're picturing a number line in your head, you should always have numbers going, increasing to the right, decreasing to the left. It's quite intuitive on the positive integer side, but negative ones, it's less clear because these numbers are getting bigger, but they're getting bigger in the negative sense. -6 is smaller than -5, -5 is smaller than -4, whereas 1 is smaller than 2. Good? So 0 is the center. Any number to the right of another number is getting larger. So we can say larger numbers. We can say the greater. And in this class, a lot of times we will talk about this as positive infinity or toward positive infinity because a line never ends. Okay? Here we have the opposite of greater, we call less than. The number is smaller, right? Even though the numerical digit is bigger, 6 is bigger than 5, and -6 is smaller than -5. Good? You can also, I labeled the whole numbers, but you can imagine the decimal numbers as well. Here's -2.7 maybe, okay? And then here would be -2.2. So all numbers are on the number line. If you continue zooming in, +6.25, you get more and more detail. Good. 0 is a neutral term. It's not really positive or negative. We have positive numbers to the right of 0 and negative numbers to the left of 0. So as we go this way, sorry, I called this way positive infinity. This way we call negative infinity. Infinity is a sideways 8. So if you're struggling with greater than or less than, visualize the number line. It might help you. Right now, it's asking us to insert a less than or greater than between the pairs of numbers. You can picture the number line. -6 is less than 6. The alligator is eating the bigger number. The alligator is eating the 6. Here are his teeth. Good. 5 is bigger than -9, so the alligator is going to eat the 5. I'll stop. -12. So 12 is bigger than 8, but -12 is smaller than -8. -2.7 is smaller than -2.1. -2.1 is going to be right here, right? And any number to the right is bigger, so that number is bigger than -2.7. 8.25 there was 6.25, 8.25. What I think of when I think of 2 5s, I think of a quarter, 25 cents. So we're saying 8 1/4 is in fact equal to 8 1/4 because you can add as many zeros as you want after a number if there is a decimal point. So 7 is the same as 7.0, just like 0.8 is equal to 8. So on this side of the decimal, we can add zeros in front of the number and not change its value. On this side of the decimal, we can add zeros behind the number and not change the value, okay? So think about that as that's 25 and that's 25, just like that's 25 and that's 25. Okay, you can add as many zeros in front of 25, it's not going to change the amount. 0 and -7/8. 0 is bigger than any negative sign, but if you're wondering what that is, you can just put it into your calculator. Oops, I had a 1 in there already. -7/8 is going to give me -0.875. Okay, so it's almost -1. It's close to -1. That's going to be less than 0. Good. Okay. Again, they're asking us to translate a sentence into a mathematical statement. Instead of equality symbols, now we're going to use inequality symbols. So I'll just read it, highlight the inequality symbol, okay? Pause the video, you try to do it by yourself. The difference of 7 and x is less than or equal to, okay? Less than or equal to. 9 is not equal to, we just put the equal sign, we put a line through it. 30 is greater than the end. The sum of 9 and x squared, greater than. Good? Okay. Now the rest of the statement. The difference of is subtraction, right? The difference of includes the and. The difference of 7 and x is less than or equal to, 21. 7x 21. Those are quite simple, so I can just pull them down. 7 is 7, x is x, 21 is 21. 9 is not equal to, x, y, plus. 9 isn't x plus y. Good? 30 is greater than the sum of, needs an and, the sum of, I know means plus, 9 and x, I just bring down like that x and like that y, x, but what is squared? What is squared? Squared means we're gonna put a little 2 above the x. I'll rewrite that because it's getting pretty excessive with the colors. So 33 is greater than 9 plus x squared, means 30 is greater than the sum of 9 and x, the squared is the 2. Squared, remember, means you're taking that x and you're multiplying it by itself 2 times. X times x is x squared. All right. Properties of real numbers. I am not going to talk about the commutative property. It is not important. I'm not going to talk about the associative property. It is not important. Therefore, we're going to go ahead in the notes. We're going to ignore this page of them, okay? That would be not worth talking about, in my opinion, for this class. The properties of real numbers. Remember we said identify the identity property? The identity property is simply that 0 plus a term is equal to that term, and 1 times that term is equal to that term. So when you're wanting to maintain equality, I don't like that I just used a because they already gave us the a example. I'm going to say 5. Okay, a is 5 now. 5 is equal to 5. If I add 1, that will change the value. If I add nothing, it's still true, okay? That's that one. And let me show you the converse. So let me cover this up. Here is 5 equals 5, right? 5 equals 5, 5 equals 5. What can you add to 5 to maintain equality? If this equal sign is here, it means we have to make sure this side is always the same as this side once it's fully simplified, okay? If I add 1, like it says right here, that will not be true, all right? That's no longer equal. If I add 0, it's still true. So that's why that is the identity property of addition or subtraction, okay? However, the identity property of multiplication is different. That same 5 equals that same 5, but now I'm going to multiply it by something. If I multiply it by 0, multiply it by 1, okay? Cover them up. 5 is equal to 5, 5 is equal to 5. 0 times 5 is equal to 5? Not true, because anything times 0 becomes 0. 0 times 5 is 0. 1 times 5 is 5, okay? So if I want to maintain the identity of a number or a term via addition, I can add 0. if I want to maintain the identity of a number via multiplication or division, I need to multiply or divide it by 1 to maintain the identity. Okay? That means if I am simplifying, for example, much later in the semester, you're going to learn that when you have a number, let's not use a letter, let's use a real number. If I have, again, 5, right? If I have 5 to the power of a -2, and I want to change that to a +2, what I need to do is I need to move it across the division bar. But this isn't, across the division bar, which is also across the fraction bar, but this isn't a fraction, right? Can I turn this into a fraction? Yes. Divide it by 1. 5 divided by 1 is still 5, whereas 5 divided by 0 is not 5. Okay, so it works the same with subtraction as it does addition, multiplication as it does division. 5 divided by 1 is still 5. 5 divided by 0 is not 5, right? 0 plus 5, 5 minus 0 is still 5, okay? So if I want to just randomly change something to a fraction, I just divide it by 1. It maintains its identity. It's still the same number. So I wanted to move it across the division bar. Now it's 5 to the +2. I can't put a 0 up here because we're talking about division and multiplication, so I'm going to put a 1 up here. Okay, that's going to come much later, don't worry. I'm sure I overwhelmed you, I regret doing that. But basically, if you're dealing with multiplication or division, you're going to use 1 to maintain equality. If you're using addition, you're going to use 0 to maintain equality. Good? Opposites just mean a number and the negative of that number are opposites because if you combine them, they will equal 0. The opposite is different from the reciprocal. So think about the opposite as 1 is positive, 1 is negative, okay? But the reciprocal is you flipped it. You have A and you have 1 over A. Just like here we had 5 to the -2 and 1 over 5 to the -2. Those are reciprocals, except that's I shouldn't delete that, right? Because I changed it from -2 to +2. Ignore, ignore, ignore. All right, reciprocal. 8 and its reciprocal will equal 1. The reciprocal of 8 is 1/8 because the reciprocal means you're taking it and you're flipping it. You're turning it into a fraction and then you're flipping that fraction, okay? 2/3 has a reciprocal of 3/2. If you multiply 2/3 by 3/2, you'll get the number 8 times 1/8 is 1. 8 divided by 1 times 1 divided by 8, 1. Okay, so it doesn't matter if you call it 8 or 8 over 1. 2/3, remember you're trying to tell me, times 3/2 equal to 1. Good, that's what a reciprocal is. So note the difference between a reciprocal and an opposite. Okay, the only property we need, we don't need commutative, we don't need associative, we just need distributive. What distributive is if something is outside of a grouping symbol, we're going to distribute it to all parts within the grouping symbol. So A times the quantity B plus C is A times B plus A times C. Good? Okay, the opposite is the same as the additive inverse. The opposite is the additive inverse, just two different ways to say the same thing. Good? So 9's opposite inverse is, you combine the two. 9's additive inverse is -9, or 9's opposite is -9. -1/8's additive inverse is, oh, guys, I did the mistake while I was about to explain not to make the mistake, is not -8/1, is not -8, is 1/8, okay? The reciprocal of -1/8 is -8, but the additive inverse of -1/8 is +1/8. Okay, I'm just going to make that a little bit clearer. So, give me a decimal. No, sorry, give me a fraction. 3/4. 3/4 reciprocal is going to be, you flip them, 4/3. Opposite or additive inverse you just change the sign. -3/4. Okay, one more time. -2 reciprocal. I have to flip the -2, and whatever is on the bottom of the fraction, if there's nothing on the bottom of the fraction, you imagine it's a 1, 1/2. It was negative, it remains negative for the reciprocal, okay? The reciprocal does not involve changing the sign. Same sign, okay? Additive inverse or opposite. Change the sign and nothing else, okay? The additive inverse of 0, think about it, is, how far away is it from 0? 0. Good. Okay. Let me just explain that the additive inverse is the additive inverse because when you combine them, they become 0. So this is true because 9 minus 9 is 0. This is true because -1/8 plus 1/8 is 0. This is true because 0 plus 0 is 0. Oh, I apologize. Got out of frame there. Okay, so that's why that is true. Now we're going to do reciprocal. The reciprocal is the same as the multiplicative inverse of each number. So if it's not a fraction, turn it into a fraction. Step 1, 11 becomes 11/1, -7 becomes -7/1, okay? Multiplicative inverse of 11/1 is, don't change the sign, 1/11. -7/1 is -1/7. 8/3 is 3/8. Don't change the sign. Positive, positive, negative, negative, positive, positive. Don't change the sign, okay? You take it, turn it into a fraction, flip the fraction around, okay? I'm not doing example 6. Example 7 is about the distributive property, very important, okay? Do not think about those other 2 properties. Think a lot about this property. 7 times the quantity x plus 4y is the same as, take that 7, apply it to the x, 7x. Take that 7, apply it to the 4y. Ooh, just keep the plus sign. 7 times 4y. Okay, that's what the distributive property is. Now we need to simplify it further. That 7x stays the same. That plus sign stays the same. Now I'm going to distribute the 7 times the 4. 7 times 4 is 28. Y. Okay. When you are combining by multiplication and you have variables and you have numbers, you multiply the numbers together, multiply the variables together. Okay. So it was 7 times 4 is 28 because I have 7 and I'm going to multiply it by 4 y's. How many y's are there? There are 4 of them. And then if I take those 4 and I multiply all of that by 7, now this one's 7, this one's 7, this one's 7, and this one's 7. 7 times each one of those. Okay, so here there was no number to multiply, so it just went from 1x to 7x's. Here it became 7 times 4 y's. It was just 4 y's. Now it's 7 times 4, or 28 y's. Okay. Same thing here. Gonna take that 3, multiply it by a -5. 3, put it in your calculator. Don't be shy. 3 times -5 is -15. No letters, so it's just -15. Okay? And then we have a plus. Take that 3, distribute it to the 9z. 3 times 9z. That -15 stays the same. Take that 3, multiply it by 9. I have 9 z's right now, but I'm going to multiply them each by 3. All 9 of them multiplied by 3 is now 27 z's. Okay, and you're done. That's as simple as you can make it. You can't add -15 and +27 because one of them is z's and the other is just 15. No z's. Good. C, this one is complicated. This one is tricky. This is the one I want you to remember the most deeply, okay? Because it will come up. It's frequent. It's an easy way to make a mistake, I'll say, okay? Negative quantity x, 8 plus x minus w, okay? Is there a number to distribute? It is an understood one. The easiest way for me to do this is to think of this as a -1. So it's not -8, negative x, and negative w. It's -1 times 8 becomes -8. -1 times positive x becomes a negative x. -1 times a negative w. If you think about what a negative times a negative does, is it makes a positive. So that's now a positive w. So don't just think of, I mean, if you want to, you can also think of, I'm just going to put a minus sign. So now it's a -8 minus x minus negative w. -8 minus x plus w. That's a perfectly fine way to think about it. But I like to think about it as a -1. I'm going to multiply -1 times 8, -1 times x, and -1 times a negative y. All right, now we're going to write these as algebraic expressions. It's not just translating from English, it's a story that you have to represent with a math equation. It's an expression, so there is no equal sign. For example, a vending machine contains X number of quarters. Write an expression for the value of the quarters. So think about, so it's a machine, it contains some quarters. How much is in the machine, right? If I had 2 quarters, what would the value be? 2 quarters, I would have, ooh, I'm sorry, you can't see it. 2 quarters is 50 cents, right? Because I multiplied 2 times 0.25. Good. Using that philosophy, take a variable, multiply it by 0.25, right? The variable is what you do not know. What is the value of the quarters? The value of the quarters is 0.25. 0.25 times x, or just 0.25x, okay? So I think about, I know, right? I know if it's 1/4, it's gonna be 25 cents. If it's 2/4, it's gonna be 50 cents. Why? Because I'm multiplying the number of quarters, or sorry, I'm multiplying the number of quarters, yes, by 25 cents, because 0.25 is the value of a quarter. Same here, the cost of y tables, if each table costs $230. Good. So one table is going to cost $230. Two tables is going to cost 230. Yikes. Times 2, right? 3 tables is going to cost that 230 times 3. What is the operation we are doing? We are doing multiplication, just like we were doing here. So every time I multiply, every time I add a table, I multiply by, or I add 230, right? So however many tables I have, I take the number of tables and I multiply by the price of the tables. So the cost of the table is going to equal how many tables you have times $230. Okay? Letter C says two numbers have a sum of 40. A sum of means we are adding them, right? One number is A, represent the other number as an expression in A. Okay? So think about it. Two numbers have a sum of 40. One number is A, represent the other number as an expression in A. If A is 10, what is the other number? The other number would be 30, because they need to add up to 40, right? You can't even see what I'm writing, I apologize. Happens so often. How do we know that? We subtracted 40 times that original term, and we got the second term, right? If 10 is A, 40 minus A is the other number. If A is 5, the other number is 35, right? Or 40 minus 5. So we have A and we have 40 minus A. They will equal 40, right? One number is A, represent the other number as an expression in A. So the other number, what they're actually asking for is 40 minus A, okay? Example D, two angles are supplementary if the sum of their measures is 180 degrees. If one angle is X, represent the other angle as an expression in X. So just like this one, 180 is X plus Y, right? But what is Y? Y is going to be just like B, right? B is 40 minus A. Y is going to be 180 minus X. Good. So the other angle is our original amount minus the X degrees. Okay, last idea is like terms. Like terms contain the same variable raised to the same power, okay? Terms are numbers and variables, okay? If you have an expression like 3x minus 5 plus 7y plus 2 minus 8x plus 4y, for example, yeah? These are 6 terms. You can count your terms by separating each term at the sign, okay? 3x is separated from -5, which is separated from 7y, which is separated from 2, which is separated from -8x, which is separated from 4y. Notice that I drew the line in front of the operation symbol. So the operations here are addition and subtraction. Subtraction makes, hold on, sorry. Subtraction makes the term negative, okay? So this is a positive term, negative term, positive term, positive term, negative term, positive term. Separate each of your terms. And like terms have the same variable raised to the same power. All right, now we've split it into terms if the term have the same variable raised to the same power, okay? We combine them. So let's talk about a term that would be the same. This is x raised to the first power. If there's no exponent here, you can assume it's a 1. This is again y raised to the first power. No variable, no variable. X raised to the first power. You don't have to call it the first power. I just wanted to make that point. Here's y raised to the first power, y raised to the first power, and then we just have some constants, -5, +2, is that it? All right, now you just combine them. So the 3x minus 8x becomes -5x. The 7y, make sure you're following the sign. So that's a -5, that's a +7y. +4y becomes a +11y. Good. And then -5 and 2 become -3. So you're left with, in the end, what you have is -5x plus 11y minus 3 by combining what are called like terms. All right, go ahead, pause the video, see if you can do the first 4 by yourself. All right, and then we will have distributive property practice. So -5 has to be distributed to the x squared, -5 has to be distributed to the -4, and then these are a bit more complicated. We'll do them together, okay? Like terms means the same variable. So go ahead and pause it. Sorry, I should have told you what I would do. I would underline the like terms, and then I would combine them. So 3x can be combined with the -5x, 8x can be combined with the 10x, -7x can be combined with the 3x. Sorry, I was sticking with the x's. I'm not going to do it down here because I need to distribute before I combine like terms, okay? The 7 has no combinable like terms. -8 and -3 are the same. +5 and -2 are the same. -5 and -7 are like terms. And then we can do 3y and -2y and +y are all like terms. Good. 3x minus 5x becomes -2x. The 7's alone, so you're done. -2x plus 7 is the simplest form of that expression. 8x and 10x become 18x. -8 minus 3 become -11. Good. -7x plus 3x. -7 plus 3 is a -4x. 5 minus 2 is 3. Good. 3y minus 2y just leaves me with y plus y. So let's look at that. 3y minus 2y's plus y. You can also, yeah, we're adding 3, subtracting 2 from that 3. So 3y, when I try to make anything similar to a bracket, I fail. 3 minus 2 is 1, right? And then 1 plus 1 is 2. So 3y minus 2y plus y is just 2y. And then -5 minus 7, they're both negative. So it's like you're adding 5 and 7 and making the answer negative. Is the same as 5 plus 7, but with a -5 in front of it, or a negative sign in front of it. Good. So 2y minus 12. Okay, down here I said we need to distribute. So we keep the 7, one second. We keep the 7x squared. We keep the positive 3, but that negative 5 is now going to get distributed. So we have negative 5 times x squared becomes negative 5x squared. And then that negative 5 gets multiplied by a negative 4. Okay, so you can call it, you don't have to write it as plus negative 5 times negative 4, but I don't want to miss any of the subtraction signs. So I'm combining x squared with a negative 4. So I'm thinking of that in my head as x squared plus negative 4 because then I can insert that negative 5 in between the plus sign and the negative 4. Or you can think of it as what it looks like, which is x squared minus 4. So then you're going to insert, so then it would be negative 5x squared minus negative 5 times 4. Okay? Either way, you're going to get the right answer. Sorry, I should explain this more. All right, let's talk about this. We have negative 5 times x squared, right? But here we have negative 5 times 4, right? Or, and what that will give us is negative 5 times 4 is a negative 20, right? So negative 5 times 4 becomes a negative 20, and there's still that minus sign in front of it. Minus a negative becomes a positive 20, okay? So you can truly look at it as minus 4, like it is, right? And then I just put that negative 5 between the minus and the 4. What I did is I said that that looks more like, just for organizational purposes, so that looked like x squared minus 4, right? And I said if I'm including a negative, I'm going to call that x squared plus negative 4. It does not matter, okay? I'm going to get the same answer. I'm going to insert a negative 5, so I'm still going to have a negative 5x squared. Now I'm going to have a plus negative 5 times negative 4. So here the minus sign is in front of both of them, and the 4 is positive. Here I left the 4 as I left the minus sign as a negative 4. So I said we're adding. It does not matter. Whichever makes more sense to you is fine. Negative 5x squared plus negative 5 times a negative 4 is a positive 20. Either way, you end up with the same, okay? It was just a bit confusing because here I said, maybe you're saying, where did that plus sign come from? The plus sign was just because I didn't want to lose the negative by accident. And then I tried to do an example here without enough space of if you didn't want to do the plus sign, you had to stick the negative 5 between the minus and the 4. Either way is fine. No, there's no wrong way. But basically we decide that that becomes negative 5x squared plus 20, right? And we still have this 7x squared plus 3 in front of it. They all get combined. Do you have like terms? Yes, in fact, you have this x squared and this x squared, so those can be combined. 7x squared minus 5x squared is just going to be 2x squared. Don't do anything special because it's a because it has a power that's not 1. We're just combining like terms, okay? That has the same x raised to the number 2. Positive 3 plus 20 can be combined, and we get 23. Good? I took up all the space and I haven't even done that one long, complicated one. So let's write it on a different piece of paper. So what they had was 1/2 times the quantity 4a minus 6b. Oh gosh, my 6's and b's are indistinguishable. Minus 1/3 times 9a plus 12b minus 1 plus 1/4. Okay, just like we distributed the negative 5, now we're going to distribute a fraction. All right, what would I do if I needed to What would I do if I needed to distribute, just means multiply, right? Distributive property, distribute a fraction. Well, you can turn everything into a fraction and multiply, right? Or you can just say that's 1 divided by 2 times 4. Negative 1 divided by 3 times 9. Okay? So here's the option where we turn them all to fractions. 1/2. What's 4 as a fraction? It's just 4 over 1. What's 6 as a fraction? Negative 6 over 1. 9 becomes 9 over 1. 12 becomes 12 over 1. 1 becomes 1 over 1 plus 1/4. Okay, and the rule for multiplying fractions is simply multiply straight across, right? Is that what you would have done if you had had to write that out? Again, same thing comes up with the negatives. I could have just called this negative. I could have put a minus sign here and multiplied negative 1/3 by a positive 1 over 1. I could have put a negative sign here. And then it would have just been a positive 1/3 times a positive 12 over 1. So just make sure that you are, whatever you're doing with your negative signs, it makes sense to you, you're preserving them, okay? Then again, we multiply straight across. 1 times 4 is 4, 2 times 1 is 2. So all of that to say that 1/2 times 4, which you're also welcome to do in your calculator, 1/2 times 4 is 2, or is 4 over 2, because 4 divided by 2 is 2, okay? Here we have a negative 1/2 times 6 over 1, so that's a minus. 1 times 6 is 6, 2 times 1 is 2. Can I keep that minus? 1 times 9 is 9, 3 times 1 is 3. Okay. It was a negative 1/3 and a plus sign here, so I'm just gonna say plus a negative is gonna become a minus. And if you did that the step earlier, that's fine. 1 times 12 is 12. 3 times 1 is 3. What you don't want to do is say that this is negative 1 and 12, negative 1 positive 12, negative 3 positive 1, because a negative 1 divided by a negative 3 is actually a positive, whereas a negative 1 divided by a positive 3 is a negative. 1 divided by a negative 3 is a negative. So you only want to put that negative in either the top or the bottom, not both. You'll cancel it out because it's actually division. So negative 1 times a negative 1 becomes a positive 1. Positive 3 times a positive 1 is a positive 3 plus 1/4. Good? So you could have done it with the calculator. That was the long way, I think. Either way, you should get to 4 divided by 2 is 2. 6 divided by 2 is 3. 9 divided by 3, and you can use your calculator. 6 divided by 2 is 3. 9 divided by 3 is also 3, right? 12 divided by 3 is a 4, plus 1/3 plus 1/4. Good? Okay. Now see if you can't combine like terms. 2a minus 3a negative 3b minus 4b. Good, so 2a minus 3a is just going to be a negative a. Negative 3b minus 4b is going to be a negative 7b plus 1/3 plus 1/4. What do we do? with 1/3 and 1/4. What you need to do when you're adding fractions is find a common denominator, okay? So if I take that 1/3 and I multiply it by 4, and I take this 1/4 and I multiply it by 3 on the top and the bottom, I will end up with 4 times 1 is 4, 4 times 3 is 12, 1 times 3 is 3, 4 times 3 is 12. 4 plus 3 is 7. Now that I have common denominators, I can add straight across. 4 plus 3 is 7, 7/12. So that finally becomes -a minus 7b plus 7/12. I would not worry about it if the fraction part did not make sense to you or was too much work for you to worry about. It will not. Nothing like that will show up on the exam. All right, guys, that is the end. I apologize for that last example. It was a bit drawn out, and I hope that you have a wonderful day. And remember, the next assignment is an exam review, and then we'll have the exam after that.